Picture this, a silent battlefield in the vast emptiness of space, where beams of light streak across the darkness, neutralizing threats before they even reach Earth. This isn't science fiction, it's the future of warfare, and it's closer than you think. Space-based energy weapons are no longer just the stuff of movies or speculative novels. They're becoming a reality, and their development could change the way we think about conflict, security, and even survival. Today, we're diving into 25 detailed predictions about the future of these groundbreaking technologies. From laser defenses that can intercept missiles in seconds to particle beams capable of disabling enemy satellites, the possibilities are as vast as space itself. But why does this matter to you? Because the decisions we make today about these weapons will shape the future of humanity, warfare, and our place in the cosmos. Stick around, because by the end of this video, you'll not only understand how these weapons work, but also how they could redefine life as we know it. Let's explore the future of space-based energy weapons together. Now, let's zoom in on the first prediction: directed energy weapons in space. Imagine a world where beams of concentrated energy, traveling at the speed of light, can neutralize threats from thousands of miles away. These weapons, often referred to as directed energy weapons or DEW, are not just theoretical anymore. They're being developed with the potential to completely transform how we approach space warfare. So, what exactly are directed energy weapons? At their core, they're systems that use focused energy, like lasers or microwaves, to damage or destroy targets. Unlike traditional weapons that rely on physical projectiles, DWs deliver energy directly to their targets, making them incredibly precise and fast. In space, where distances are vast and reaction times are critical, this precision is a game changer. One of the most promising applications of DWs in space is satellite defense. Satellites are the backbone of modern communication, navigation, and surveillance systems. Protecting them from potential attacks is crucial. Directed energy weapons could be used to disable or destroy incoming threats like missiles or hostile satellites before they can cause harm. This would create a protective shield around critical space infrastructure, ensuring that our global networks remain secure. But the potential of DWs doesn't stop there. They could also play a vital role in planetary protection. For instance, imagine a scenario where an asteroid is on a collision course with Earth. A space-based directed energy weapon could be used to either deflect the asteroid or break it into smaller, less dangerous pieces. This capability could one day save our planet from catastrophic impacts. What makes DWs truly revolutionary is their ability to operate without the limitations of traditional weapons. They don't require ammunition, which means they can be used repeatedly as long as they have a power source. In space, where resupplying is nearly impossible, this is a huge advantage. Additionally, because they rely on energy rather than explosives, DWs could reduce the risk of creating space debris, which is already a growing concern in Earth's orbit. The deployment of directed energy weapons in space could mark the beginning of a new era in warfare, one where speed, precision, and sustainability take center stage. But as with any powerful technology, there are questions about how these weapons will be used and regulated. Who gets to control them? How do we prevent them from being misused? These are challenges that will need to be addressed as we move forward. As we continue exploring the future of space-based energy weapons, it's clear that DWs are just the beginning. Next, we'll dive into how laser-based defense systems could further enhance our ability to protect Earth and beyond. Stay tuned, because the future of space warfare is more fascinating and complex than ever before. Now, shifting our focus to the next frontier in space-based energy weapons, let's explore the potential of laser-based defense systems. Picture this: a network of high-powered lasers stationed in orbit, capable of detecting and neutralizing threats in the blink of an eye. These systems represent a leap forward in our ability to protect not just Earth, but also our assets in space from a wide range of dangers. Laser-based defense systems work by focusing intense beams of light onto a target, heating it to the point of destruction or disruption. Unlike traditional missile defense systems, which rely on physical interceptors, lasers can strike with pinpoint accuracy at the speed of light. This makes them ideal for countering fast-moving threats, such as ballistic missiles or even hypersonic weapons, which are nearly impossible to stop using conventional methods. One of the most exciting applications of these systems is their ability to intercept missiles during their boost phase the moment they're launched. By targeting missiles early in their flight, laser-based defenses could neutralize them before they reach their full speed or deploy countermeasures. This would not only protect cities and military installations on Earth, but also reduce the risk of debris from destroyed missiles cluttering space. But the potential of laser-based defense systems extends beyond Earth's atmosphere. In space, these lasers could be used to disable or destroy hostile satellites, ensuring that critical communication and surveillance networks remain operational. They could also serve as a deterrent against attacks on space infrastructure, creating a safer environment for exploration and commerce. Another intriguing possibility is their use in planetary defense. Imagine a scenario where a rogue asteroid or comet is detected heading toward Earth. A space-based laser system could be deployed to either vaporize the object or alter its trajectory, preventing a catastrophic impact. This capability could one day become a vital tool in safeguarding our planet from cosmic threats. What sets laser-based systems apart is their versatility and efficiency. They don't rely on physical ammunition, meaning they can be used repeatedly as long as they have a sufficient power source. In space where resources are limited, this is a significant advantage. Additionally, because lasers produce minimal debris compared to explosive weapons, they could help mitigate the growing problem of space junk. Of course, the development of laser-based defense systems isn't without challenges. Powering these systems requires substantial energy, and maintaining their precision over vast distances is no small feat. Advances in energy storage and beam control will be critical to making these systems viable on a large scale. As we look to the future, it's clear that laser-based defense systems could play a pivotal role in securing both Earth and space. Their speed, precision, and adaptability make them a powerful tool in the evolving landscape of space warfare. But as with any advanced technology, questions about their regulation and ethical use will need to be addressed. With that in mind, let's turn our attention to the next prediction: particle beam weapons. These futuristic systems take energy-based warfare to a whole new level, offering capabilities that could redefine how we think about combat in space. Stay tuned, because the future of space-based energy weapons is just getting started. Now, let's dive into the fascinating world of particle beam weapons, a technology that sounds like it's straight out of science fiction but is rapidly becoming a reality. Unlike lasers, which use concentrated light, particle beams rely on streams of charged particles like protons or electrons accelerated to incredible speeds. When these particles collide with a target, they deliver a devastating burst of energy, capable of disabling or destroying it with remarkable precision. The science behind particle beam weapons is rooted in particle accelerators, the same technology used in laboratories to study the fundamental building blocks of matter. By accelerating particles to near light speeds and focusing them into a tight beam, these weapons can deliver energy with pinpoint accuracy. This makes them particularly effective in space, where the lack of atmosphere allows the beam to travel vast distances without losing its intensity. One of the most compelling advantages of particle beam weapons is their ability to penetrate deep into a target. While lasers primarily affect the surface of an object, particle beams can disrupt internal systems, such as electronics or propulsion mechanisms, without causing visible damage. This makes them ideal for disabling enemy satellites or spacecraft, as they can incapacitate critical systems while leaving the overall structure intact. In space warfare, this precision could be a game changer. Imagine a scenario where an adversary satellite is interfering with global communications. A particle beam weapon could target the satellite's power supply or communication array, rendering it useless without creating dangerous debris that could threaten other spacecraft. This level of control could help maintain the delicate balance of space infrastructure, ensuring that conflicts don't spiral out of control. Another potential application is in defending against incoming threats such as missiles or hostile drones. Particle beams could be used to disable the guidance systems of these weapons, causing them to veer off course or self-destruct. This would provide an additional layer of defense, complementing existing technologies like lasers and missile interceptors. However, developing particle beam weapons for space isn't without its challenges. Generating and maintaining the high-energy beams requires significant power, and the equipment needed to accelerate particles is currently bulky and complex. Advances in miniaturization and energy efficiency will be crucial to making these weapons practical for deployment in orbit. Despite these hurdles, the potential of particle beam weapons is undeniable. Their precision, versatility, and ability to operate in the vacuum of space make them a promising addition to the arsenal of space-based energy weapons. As research continues, we may see these systems play a key role in shaping the future of space warfare and defense. With that in mind, let's shift our focus to the next frontier: microwave energy weapons. These systems take a different approach, using electromagnetic waves to disrupt electronics and communication systems without causing physical destruction. Stay tuned, because the future of space-based energy weapons is full of surprises. Now, let's explore the intriguing realm of microwave energy weapons, a technology that operates on a completely different principle compared to lasers or particle beams. Unlike those systems which rely on concentrated light or charged particles, microwave weapons harness electromagnetic waves to achieve their effects. These waves, similar to the ones used in your kitchen microwave but far more powerful, can target and disrupt electronic systems with remarkable precision. The key advantage of microwave energy weapons lies in their ability to disable electronics without causing physical damage. Imagine a scenario where an enemy satellite is jamming critical communication signals. A microwave weapon could emit a focused beam of electromagnetic energy, overwhelming the satellite's circuits and rendering it inoperable, all without leaving a scratch on its exterior. This makes microwave weapons particularly valuable in situations where preserving the physical integrity of a target is essential, such as in space where debris from destroyed satellites could pose a significant hazard. One of the most compelling applications of microwave weapons is their potential to neutralize threats from a distance. For instance, they could be used to disable the guidance systems of incoming missiles or drones, causing them to malfunction or self-destruct. This capability could provide a critical layer of defense, especially in scenarios where traditional interceptors or lasers might be less effective. Another fascinating aspect of microwave energy weapons is their ability to penetrate through materials that might block other forms of energy. While lasers can be deflected or absorbed by certain surfaces, microwaves can pass through obstacles like clouds or even some types of shielding, making them highly versatile in diverse environments. This characteristic could prove invaluable in space, where conditions can vary widely depending on the mission or location. However, deploying microwave weapons in space isn't without its challenges. Generating the high-power electromagnetic waves required for these systems demands significant energy, and the equipment needed to produce and focus these waves can be complex and bulky. Advances in energy efficiency and miniaturization will be crucial to making microwave weapons a practical option for space-based applications. Despite these hurdles, the potential of microwave energy weapons is immense. Their ability to disrupt electronics without causing physical destruction offers a unique advantage in both offensive and defensive scenarios. As research and development continue, we may see these systems play a pivotal role in shaping the future of space warfare, providing a non-lethal yet highly effective tool for maintaining security and stability in orbit. With that in mind, let's turn our attention to another groundbreaking concept: space-based railguns. These weapons take a more traditional approach, using kinetic energy to deliver devastating force, but with a futuristic twist that makes them uniquely suited for the challenges of space. Stay tuned, because the future of space-based energy weapons is just getting started. Now, shifting gears to a more kinetic approach, let's dive into the fascinating world of space-based railguns. Unlike energy-based weapons that rely on lasers or microwaves, railguns operate on the principle of kinetic energy, launching projectiles at incredible speeds. These futuristic weapons could redefine how we think about space warfare, offering a blend of raw power and precision that traditional projectile systems simply can't match. One of the standout advantages of railguns is their ability to fire projectiles at hypersonic speeds, reaching velocities that make them nearly impossible to intercept. In space, where there's no air resistance to slow them down, these projectiles could travel vast distances with pinpoint accuracy. Imagine a scenario where an enemy satellite is threatening critical infrastructure. A railgun could launch a projectile from a safe distance, striking the target with enough force to disable or destroy it without the need for explosives. This makes railguns a highly effective tool for both offensive and defensive operations in orbit. Another key benefit of railguns is their reliance on kinetic energy rather than chemical propellants. Traditional projectile weapons, like missiles, require explosive warheads and fuel, which add weight and complexity to the system. Railguns, on the other hand, use electromagnetic forces to accelerate their projectiles, eliminating the need for bulky and volatile components. This not only reduces the risk of accidental detonation, but also allows for a more compact and efficient design, which is crucial for space-based applications where every kilogram of payload matters. Railguns also offer a unique advantage in terms of cost-effectiveness. Once the initial system is in place, the cost of firing projectiles is relatively low compared to traditional weapons. The projectiles themselves are typically made of dense materials like tungsten, which are durable and inexpensive to produce. This makes railguns an attractive option for sustained operations in space, where resupply missions can be costly and logistically challenging. However, deploying railguns in space isn't without its challenges. The immense energy required to accelerate projectiles to hypersonic speeds demands a reliable and powerful energy source. Solar power could be a viable option, but advancements in energy storage and distribution will be essential to make railguns a practical reality. Additionally, the recoil generated by firing a railgun could pose challenges for stabilizing the platform in the zero-gravity environment of space. Engineers will need to develop innovative solutions to counteract these forces and ensure the weapon remains accurate and effective. Despite these hurdles, the potential of space-based railguns is undeniable. Their combination of speed, precision, and cost-effectiveness makes them a formidable addition to the arsenal of future space-based weapons. Whether used to defend critical assets or neutralize threats from a distance, railguns could play a pivotal role in shaping the future of space warfare. As we continue to explore the possibilities of space-based energy weapons, let's turn our attention to another innovative concept: solar-powered energy weapons. These systems could revolutionize how we think about sustainability and efficiency in space, offering a greener and more self-sufficient approach to powering advanced weaponry. Stay tuned, because the future of space-based energy weapons is full of surprises. Now, let's take a closer look at a concept that could redefine sustainability in space warfare: solar-powered energy weapons. Imagine a future where the vast, untapped energy of the sun becomes the primary source of power for advanced weaponry in orbit. This isn't just a futuristic dream, it's a practical solution that could drastically reduce our reliance on Earth-based resources while making space-based systems more self-sufficient and environmentally friendly. Solar-powered energy weapons would operate by capturing sunlight through massive solar arrays, converting it into electricity and storing it in high-capacity batteries or capacitors. This stored energy could then be used to power a variety of weapons, from lasers and particle beams to railguns and microwave systems. The beauty of this approach lies in its simplicity and efficiency. Unlike traditional energy sources that require constant resupply, solar energy is abundant and renewable, making it an ideal choice for long-term operations in space. One of the most significant advantages of solar-powered weapons is their sustainability. By harnessing the sun's energy, these systems could operate indefinitely without the need for frequent refueling missions from Earth. This not only reduces the logistical burden but also minimizes the risk of supply chain disruptions during conflicts. In a high-stakes environment like space, where every second counts, having a reliable and continuous energy source could be a game-changer. Another key benefit is the potential for scalability. Solar arrays can be designed to expand as needed, allowing for the gradual increase of energy output to meet growing demand. This flexibility makes solar-powered weapons adaptable to a wide range of missions, from defending satellites and space stations to neutralizing threats from asteroids or hostile spacecraft. Additionally, advancements in solar panel technology, such as lightweight and highly efficient designs, could further enhance the performance of these systems, making them even more viable for space-based applications. However, there are challenges to consider. Solar energy is dependent on the availability of sunlight, which means that weapons positioned in areas with limited exposure, such as the dark side of a planet or during eclipses, might face energy shortages. To address this, engineers would need to develop robust energy storage solutions capable of maintaining power levels during periods of low sunlight. Innovations in battery technology, such as solid-state or graphene-based batteries, could play a crucial role in overcoming this hurdle. Despite these challenges, the potential of solar-powered energy weapons is immense. They represent a shift toward more sustainable and efficient space-based systems, aligning with the broader goals of reducing humanity's environmental footprint even beyond Earth. By leveraging the power of the sun, we could create a new generation of weapons that are not only effective but also environmentally conscious. As we continue to explore the possibilities of space-based energy weapons, let's turn our attention to another critical aspect of space warfare: anti-satellite energy weapons. These systems could fundamentally alter the balance of power in orbit, creating new challenges and opportunities for nations venturing into the final frontier. Stay tuned, because the future of space-based energy weapons is as vast and unpredictable as the cosmos itself. Now, shifting our focus to a more strategic aspect of space warfare, let's explore the concept of anti-satellite energy weapons. These systems represent a significant evolution in military technology, with the potential to disrupt or destroy enemy satellites, fundamentally altering the dynamics of conflict in orbit. Anti-satellite energy weapons, often referred to as ASAT systems, could employ a variety of energy-based technologies to neutralize satellites. For instance, high-powered lasers could be used to damage or blind satellite sensors, rendering them ineffective. Alternatively, particle beam weapons could target critical components, such as solar panels or communication arrays, disabling the satellite without causing explosive debris that could endanger other spacecraft. Microwave energy weapons, on the other hand, could disrupt a satellite's electronics, effectively shutting it down without physical destruction. The implications of such technology are profound. Satellites play a crucial role in modern warfare, providing communication, navigation, surveillance, and intelligence capabilities. By targeting these assets, anti-satellite energy weapons could cripple an adversary's ability to coordinate military operations, gather real-time data, or even maintain global communication networks. This creates a new frontier in space warfare, where control over orbital assets could determine the outcome of conflicts on Earth. One of the key advantages of energy-based ASAT systems is their precision. Unlike traditional kinetic anti-satellite weapons, which rely on physical collisions and can generate dangerous space debris, energy weapons offer a cleaner and more controlled approach. This precision reduces the risk of collateral damage, making them a more attractive option for nations seeking to maintain a strategic edge without escalating tensions unnecessarily. However, the development and deployment of anti-satellite energy weapons also raise significant challenges. For one, the technology required to effectively target and disable satellites from vast distances is incredibly complex. Satellites move at high speeds and are often shielded against radiation, requiring energy weapons to deliver precise and sustained bursts of power. Additionally, the legal and ethical implications of destroying or disabling satellites could spark international controversy, as such actions might be seen as acts of aggression or violations of space treaties. Despite these challenges, the potential of anti-satellite energy weapons cannot be ignored. They represent a shift toward more sophisticated and less destructive forms of space warfare, where the goal is not necessarily to obliterate an enemy's assets but to render them ineffective. This approach aligns with the broader trend of minimizing collateral damage and preserving the usability of space for all nations. As we look ahead, the development of anti-satellite energy weapons will likely prompt new discussions about the militarization of space and the need for international regulations. The balance between maintaining national security and ensuring the peaceful use of space will be a critical issue for the global community to address. With this in mind, let's turn our attention to another groundbreaking concept: space-based electromagnetic pulse weapons. These systems could take the disruption of enemy capabilities to an entirely new level, reshaping the future of space warfare in ways we are only beginning to understand. Stay tuned, because the next chapter in this story is just as fascinating as the last. Now, let's dive into a concept that could redefine the very nature of space warfare: space-based electromagnetic pulse weapons, or EMP. Imagine a weapon so powerful that it could disable not just one satellite, but an entire fleet of them with a single burst of energy. This is the potential of EMP weapons deployed in space, and it's a game-changer for both military strategy and global security. At their core, EMP weapons generate a massive burst of electromagnetic energy capable of overwhelming and frying the electronics of any satellite or spacecraft within range. Unlike traditional weapons that rely on physical destruction, EMPs target the intricate circuitry and systems that keep satellites operational. A well-placed EMP could render communication satellites useless, disrupt navigation systems, and even disable military reconnaissance platforms, all without leaving a trace of debris. This makes EMPs a uniquely clean yet devastating tool in the arsenal of space-based warfare. The implications of such technology are staggering. Satellites are the backbone of modern infrastructure, supporting everything from global communications to financial transactions and military operations. A single EMP attack in space could cripple a nation's ability to coordinate its defenses, gather intelligence, or even maintain basic communication networks. The ripple effects would be felt not just on the battlefield, but across entire economies and societies. One of the most intriguing aspects of space-based EMP weapons is their scalability. A small-scale EMP could target a specific satellite or a cluster of satellites, while a larger burst could disable an entire orbital region. This flexibility makes EMPs a versatile tool for both precision strikes and broader strategic disruptions. For example, a nation could use a targeted EMP to neutralize an adversary's spy satellites during a conflict, or deploy a larger pulse to disrupt global communication networks as part of a broader geopolitical strategy. However, the development and use of EMP weapons also come with significant challenges and risks. For one, the technology required to generate and deliver a powerful enough EMP in space is incredibly complex. Satellites are designed to withstand certain levels of radiation, so an EMP weapon would need to produce an energy burst strong enough to overcome these protections. Additionally, the indiscriminate nature of EMPs means that even friendly or neutral satellites could be affected, raising the risk of unintended consequences and diplomatic fallout. The geopolitical implications of space-based EMP weapons are equally profound. The ability to disable satellites at will could shift the balance of power in space, giving nations with this technology a significant strategic advantage. However, it could also lead to an arms race as other countries rush to develop their own EMP capabilities or countermeasures. This raises critical questions about the future of space governance and the need for international agreements to prevent the weaponization of space. Despite these challenges, the potential of space-based EMP weapons is undeniable. They represent a new frontier in warfare, where the battlefield extends beyond Earth's atmosphere and the stakes are higher than ever. As we continue to explore the possibilities of this technology, one thing is clear: the future of space-based energy weapons is as complex as it is fascinating. With that in mind, let's turn our attention to another critical development in this field: orbital defense platforms. These structures could serve as the first line of defense against incoming threats, reshaping how we think about protecting our assets in space. Stay tuned, because the next chapter in this story is just as compelling as the last. Now, let's shift our focus to a concept that could redefine how we protect our assets in space: orbital defense platforms. Picture massive structures orbiting Earth, armed with advanced energy weapons, ready to intercept and neutralize threats before they can cause harm. These platforms could serve as the ultimate guardians of our space infrastructure, offering a first line of defense against everything from rogue asteroids to hostile spacecraft. Orbital defense platforms represent a significant leap forward in space security. Unlike ground-based systems, which are limited by Earth's atmosphere and geography, these platforms operate in the vacuum of space, giving them unparalleled range and precision. Equipped with energy weapons like lasers or particle beams, they could target and destroy incoming missiles, debris, or even enemy satellites with incredible accuracy. This makes them a critical component of any future space defense strategy. One of the most compelling aspects of these platforms is their versatility. They could be designed to handle a wide range of threats, from small, fast-moving projectiles to larger, more complex targets. For example, a laser-equipped platform could focus its beam on a single missile, vaporizing it in seconds, while a particle beam system could disable multiple targets simultaneously. This adaptability ensures that orbital defense platforms remain effective in a variety of scenarios, whether defending against a coordinated attack or responding to an unexpected threat. The strategic advantages of orbital defense platforms are immense. By positioning these platforms in key orbits, nations could create a protective shield around their most valuable assets, such as communication satellites, space stations, or even future lunar bases. This not only enhances security, but also deters potential adversaries from attempting an attack, knowing that any hostile action could be swiftly countered. In this way, orbital defense platforms could serve as both a defensive tool and a powerful deterrent. However, the development of these platforms is not without its challenges. Building and maintaining such structures in space requires cutting-edge technology and significant resources. The energy weapons themselves must be powerful enough to neutralize threats while being efficient enough to operate continuously without draining the platform's power supply. Additionally, the platforms would need to be equipped with advanced sensors and artificial intelligence systems to detect and respond to threats in real time, ensuring they can act quickly and effectively. The geopolitical implications of orbital defense platforms are equally significant. Nations with the capability to deploy and control these platforms would hold a considerable advantage in space, potentially shifting the balance of power. This could lead to increased competition and even conflict as countries race to develop their own orbital defense systems. At the same time, it raises important questions about international cooperation and the need for agreements to prevent the militarization of space. Despite these challenges, the potential benefits of orbital defense platforms are undeniable. They offer a proactive approach to space security, allowing us to protect our assets and maintain stability in an increasingly crowded and contested environment. As we continue to explore the possibilities of this technology, one thing is clear: the future of space defense is not just about reacting to threats, but about preventing them before they can even begin. With that in mind, let's turn our attention to another fascinating development in the realm of space-based energy weapons, energy shields and countermeasures. These technologies could revolutionize how we protect spacecraft and satellites, creating a new arms race in the stars. Stay tuned, because the next chapter in this story is just as groundbreaking as the last. Now let's venture into a concept that sounds like it's straight out of science fiction but could soon become a reality: energy shields and countermeasures. Imagine spacecraft and satellites surrounded by invisible barriers, deflecting or absorbing energy-based attacks before they can cause any damage. This isn't just a futuristic dream, it's a potential game changer in the realm of space defense. Energy shields work by creating a protective field around a spacecraft or satellite, capable of neutralizing incoming threats like lasers, particle beams, or even electromagnetic pulses. These shields could be generated using advanced technologies such as plasma fields or electromagnetic barriers, which would act as a buffer against hostile energy weapons. The idea is to create a defense system that can adapt to different types of attacks, ensuring that critical space assets remain safe from harm. One of the most exciting aspects of energy shields is their potential to level the playing field in space warfare. Currently, satellites and spacecraft are highly vulnerable to energy-based attacks, with little to no protection against such threats. Energy shields could change that, providing a robust defense mechanism that makes it much harder for adversaries to disable or destroy these assets. This could lead to a new era of space security, where the focus shifts from offensive capabilities to defensive innovations. But energy shields aren't just about defense. They could also spark a new arms race in space. As nations develop more advanced energy weapons, the need for equally sophisticated countermeasures will grow. This could drive rapid advancements in shield technology, with countries competing to create the most effective and resilient systems. In turn, this competition could accelerate the development of other space technologies, from propulsion systems to power generation, as nations strive to outpace their rivals. Of course, developing energy shields is no small feat. The technology required to generate and maintain these protective fields is incredibly complex, requiring breakthroughs in energy efficiency, materials science, and artificial intelligence. For example, shields would need to be powered by a reliable and sustainable energy source, capable of operating continuously without draining the spacecraft's resources. Additionally, the shields would need to be controlled by advanced AI systems, capable of detecting and responding to threats in real time. The implications of energy shields extend beyond just military applications. They could also play a crucial role in protecting civilian space infrastructure, such as communication satellites or space stations, from accidental collisions or space debris. By creating a safer environment in orbit, energy shields could help pave the way for more ambitious space exploration and colonization efforts, ensuring that humanity's presence in space is both secure and sustainable. As we look to the future, it's clear that energy shields and countermeasures could redefine how we think about space defense. They offer a proactive solution to the growing threats in orbit, providing a layer of protection that could make all the difference in a conflict. But they also raise important questions about the balance of power in space and the potential for an escalating arms race. As we continue to explore this technology, one thing is certain: the stars may soon be shielded, but the competition to dominate them will only grow fiercer. With that in mind, let's turn our attention to another groundbreaking application of space-based energy weapons: their potential role in defending Earth from catastrophic asteroid impacts. This next chapter in our exploration is just as thrilling as the last, so stay tuned. Now, let's shift our focus to a scenario that could literally save the planet: the use of space-based energy weapons for asteroid defense. Imagine a massive asteroid hurtling toward Earth, threatening to cause widespread destruction. Instead of relying on traditional methods like nuclear explosives, we could deploy energy weapons to either deflect or destroy the asteroid before it reaches us. This isn't just a plot from a disaster movie, it's a real possibility that could redefine how we protect our planet. Energy weapons, such as high-powered lasers or particle beams, could be used to target asteroids with incredible precision. By focusing intense energy on the asteroid's surface, these weapons could either vaporize parts of it, creating a thrust that alters its trajectory, or break it into smaller, less dangerous pieces. The key advantage here is precision. Unlike nuclear explosions, which can be unpredictable and risky, energy weapons offer a controlled and targeted approach to asteroid defense. One of the most promising applications of this technology is in deflecting near-Earth objects, or NEO, that pose a threat to our planet. By stationing energy weapons in space, we could intercept these objects long before they enter Earth's atmosphere, giving us more time to respond and reducing the risk of catastrophic impact. This approach would require advanced detection systems to identify potential threats early, as well as a network of energy weapons strategically placed in orbit to act as a planetary defense shield. But how feasible is this technology? While the concept is still in its early stages, significant progress has already been made. For example, ground-based laser systems have been tested for their ability to alter the trajectory of small objects. Scaling this up to space-based systems would require overcoming challenges like power generation and heat dissipation, but the potential benefits are enormous. By developing energy weapons for asteroid defense, we could not only protect Earth but also gain valuable insights into the behavior of asteroids, which could inform future space exploration missions. Another exciting aspect of this technology is its potential for international collaboration. Asteroid defense is a global concern, and the development of space-based energy weapons could bring nations together to work toward a common goal. Imagine a future where countries pool their resources and expertise to create a unified planetary defense system, ensuring that no asteroid poses a threat to humanity. This kind of cooperation could set a precedent for other space-related initiatives, fostering a spirit of unity in the face of shared challenges. Of course, there are ethical and practical considerations to address. For instance, who would control these weapons and how would decisions about their use be made? Additionally, the potential for misuse or accidental harm must be carefully managed. However, the benefits of protecting Earth from catastrophic impacts far outweigh the risks, making this a compelling area of research and development. As we look to the future, the idea of using space-based energy weapons for asteroid defense offers a glimpse of what's possible when we combine cutting-edge technology with a commitment to safeguarding our planet. It's a reminder that the tools we develop for space exploration and defense can have profound implications for life on Earth. And with that, let's move on to another fascinating application of space-based energy weapons: their integration with artificial intelligence, which could take their capabilities to a whole new level. Now, let's take a closer look at how artificial intelligence could revolutionize the way we think about space-based energy weapons. Picture this: a fleet of satellites equipped with advanced energy weapons, all controlled by artificial intelligence systems capable of making split-second decisions. This isn't just about adding a layer of automation. It's about creating a new paradigm in space defense, where speed, precision, and adaptability are taken to unprecedented levels. Artificial intelligence could enable these weapons to operate autonomously, analyzing threats in real time and responding faster than any human operator ever could. Imagine an incoming missile or hostile spacecraft being detected by sensors. An AI-controlled energy weapon could instantly calculate the optimal response, whether that's firing a laser beam, deploying a particle beam, or activating a countermeasure, all within milliseconds. This kind of rapid decision-making could be the difference between success and failure in high-stakes scenarios. One of the most significant advantages of integrating artificial intelligence is its ability to learn and adapt. Unlike traditional systems that rely on pre-programmed responses, AI can analyze vast amounts of data, identify patterns, and improve its performance over time. For example, an AI system could study the behavior of enemy satellites or spacecraft, predict their next moves, and adjust its tactics accordingly. This adaptability makes AI-controlled energy weapons not only more effective, but also more resilient in the face of evolving threats. But the benefits don't stop there. Artificial intelligence could also enhance the coordination of multiple energy weapons, creating a network defense system that operates as a unified force. Imagine a swarm of satellites working together, each one communicating with the others to share information and coordinate attacks. This kind of synergy would make it nearly impossible for an adversary to overwhelm the system, as the AI could dynamically allocate resources to address the most pressing threats. Of course, the integration of artificial intelligence into space-based energy weapons also raises important questions. How do we ensure that these systems make ethical decisions? What safeguards are needed to prevent malfunctions or misuse? These are critical issues that must be addressed as we move forward with this technology. However, the potential benefits, faster response times, greater precision, and enhanced adaptability make it a compelling area of research and development. As we explore the possibilities of AI-controlled energy weapons, it's clear that this technology could redefine the future of space defense. By combining the power of artificial intelligence with the precision of energy weapons, we could create a system that not only protects our planet, but also opens up new possibilities for space exploration and security. And with that, let's turn our attention to another exciting application of space-based energy weapons, their potential role in space mining, where they could unlock valuable resources from asteroids and other celestial bodies. Now, shifting our focus to a more constructive application of space-based energy weapons, let's explore how these powerful tools could revolutionize space mining. Imagine a future where energy weapons are not just instruments of defense, but also key players in unlocking the vast resources of our solar system. By repurposing these technologies, we could transform the way we extract valuable materials from asteroids, moons, and other celestial bodies. Energy weapons, such as high-powered lasers or particle beams, could be used to break down the surface of asteroids, making it easier to access the metals, minerals, and rare elements hidden within. For example, a laser beam could vaporize rock and ice, allowing mining equipment to collect the resulting debris. This method would be far more efficient than traditional drilling or excavation, especially in the low-gravity environment of space. One of the biggest challenges in space mining is the sheer hardness of many asteroids, which are often composed of dense metals like iron and nickel. Energy weapons could provide a solution by precisely targeting and fragmenting these tough materials, making them easier to process. This precision could also minimize waste, ensuring that valuable resources are extracted with maximum efficiency. Another advantage of using energy weapons for space mining is their ability to operate remotely. mining operations in space are inherently risky with harsh conditions and limited human presence. By deploying energy weapons on autonomous or remotely controlled platforms, we could reduce the need for human intervention, making the process safer and more cost-effective. Beyond asteroids, energy weapons could also be used to extract resources from moons or even planets. For instance, a particle beam could be used to carve out sections of a moon's surface, revealing deposits of water ice or other valuable materials. This capability could be crucial for supporting long-term space exploration and colonization efforts, providing the raw materials needed to build habitats, fuel spacecraft, and sustain life. Of course, repurposing energy weapons for mining raises its own set of challenges. How do we ensure that these powerful tools are used responsibly and sustainably? What safeguards are needed to prevent environmental damage or conflicts over resource extraction? These are important questions that will need to be addressed as we move forward with this technology. Despite these challenges, the potential benefits are immense. By harnessing the power of energy weapons for space mining, we could unlock a new era of resource abundance, fueling advancements in technology, exploration, and even life beyond Earth. And with that, let's turn our attention to another critical aspect of space-based energy weapons, the international regulations that will shape their development and use. Now, let's pivot to a topic that's as complex as it is crucial: the role of international regulations in governing space-based energy weapons. As these technologies advance, the need for clear rules and agreements becomes more pressing. Without a framework to guide their use, the potential for misuse or conflict in space could escalate rapidly. The idea of international treaties regulating space weapons isn't new. In fact, the Outer Space Treaty of 1967 laid the groundwork by prohibiting the placement of weapons of mass destruction in space. However, this treaty doesn't specifically address energy weapons, leaving a significant gap in the legal framework. As nations develop and deploy these advanced systems, the question of how to regulate them becomes increasingly urgent. One of the biggest challenges in creating effective regulations is the dual-use nature of space-based energy weapons. These systems can serve both peaceful and military purposes, making it difficult to draw clear lines between acceptable and unacceptable uses. For example, a laser designed to deflect asteroids could also be repurposed to disable satellites. This ambiguity complicates efforts to establish clear rules and enforce them. Another hurdle is the lack of a centralized authority to oversee space activities. Unlike Earth, where nations can rely on organizations like the United Nations to mediate disputes, space remains a largely ungoverned frontier. This absence of a governing body makes it harder to monitor compliance with treaties and address violations. Without a robust enforcement mechanism, even well-intentioned agreements may struggle to have a meaningful impact. Enforcement is further complicated by the technical challenges of monitoring space-based activities. Detecting the use of energy weapons in the vastness of space is no easy task. Unlike traditional weapons, which leave visible traces, energy weapons can be used with little to no physical evidence. This makes it difficult to prove violations and hold nations accountable. Despite these challenges, there are steps that could be taken to strengthen international regulations. One approach is to establish transparency measures, such as requiring nations to share information about their space-based systems and activities. This could help build trust and reduce the risk of misunderstandings or accidental conflicts. Another option is to create a dedicated international body tasked with monitoring space activities and enforcing compliance with treaties. Of course, achieving consensus on these measures won't be easy. Nations have differing priorities and concerns when it comes to space security, and reaching agreement will require careful negotiation and compromise. However, the stakes are too high to ignore. Without effective regulations, the risk of an arms race in space, or even outright conflict, becomes all too real. As we look to the future, it's clear that international cooperation will be essential in shaping the responsible use of space-based energy weapons. By working together, nations can create a framework that balances innovation with security, ensuring that these powerful technologies are used for the benefit of all humanity. And with that, let's turn our attention to another fascinating possibility: the use of energy weapons in lunar warfare. Now, let's shift our gaze to the Moon, where the next frontier of space-based energy weapons could unfold. As humanity sets its sights on lunar colonization, the Moon could become not just a scientific outpost but also a strategic battleground. Energy weapons, with their precision and versatility, might play a key role in shaping the future of lunar warfare and defense. Imagine a scenario where nations establish permanent bases on the Moon. These bases would need protection from potential threats, whether from rival nations, rogue actors, or even natural hazards. Energy weapons, such as lasers or particle beams, could serve as a first line of defense. Their ability to neutralize incoming threats like missiles or hostile drones without the need for traditional ammunition makes them ideal for the resource-limited environment of the Moon. But energy weapons on the Moon wouldn't just be about defense. They could also be integral to a broader lunar colonization strategy. For instance, lasers could be used to clear landing zones by vaporizing debris or smoothing out rough terrain. Particle beams might help in mining operations, breaking down lunar rock to extract valuable resources like water or rare minerals. In this way, energy weapons could transition from tools of war to instruments of progress, supporting the sustainable development of lunar settlements. However, the deployment of energy weapons on the Moon raises significant ethical and strategic questions. Who gets to control these weapons, and under what circumstances can they be used? The Moon, unlike Earth, has no established legal framework for military activities. This lack of regulation could lead to tensions or even conflicts as nations compete for lunar resources and territory. The potential for an arms race on the Moon is a real concern, especially as more countries and private entities aim to establish a presence there. Another challenge is the technical complexity of operating energy weapons in the harsh lunar environment. The Moon's lack of atmosphere means there's no natural protection from solar radiation or micrometeoroids, which could damage sensitive equipment. Additionally, the extreme temperature fluctuations between lunar day and night could affect the performance and durability of these systems. Overcoming these challenges will require innovative engineering and robust infrastructure. Despite these hurdles, the strategic advantages of energy weapons on the Moon are hard to ignore. They offer a way to protect assets, secure resources, and assert dominance in a new frontier. As lunar colonization becomes more feasible, the role of energy weapons in shaping the Moon's future will likely grow. Whether for defense, resource extraction, or territorial control, these technologies could redefine what it means to operate beyond Earth. With the Moon as a potential stage for energy weapon deployment, the next logical step is to consider how these technologies might intersect with another pressing global issue: climate change. Let's explore how space-based energy weapons could play a role in addressing one of humanity's greatest challenges. Now, let's turn our attention to a surprising and potentially transformative application of space-based energy weapons: their role in combating climate change. While these technologies are often associated with warfare and defense, they could also serve as powerful tools to address one of humanity's most pressing challenges. Imagine a future where energy weapons are not just instruments of destruction, but also solutions for planetary preservation. One of the most promising ideas involves using space-based energy weapons to manage solar radiation. By deploying advanced laser or particle beam systems in orbit, we could potentially deflect a portion of the sun's rays away from Earth. This concept, known as solar radiation management, aims to reduce the amount of heat reaching our planet, thereby mitigating the effects of global warming. While still in the realm of theoretical science, the precision and scalability of energy weapons make them a compelling option for such a task. Another possibility is the use of energy weapons to manipulate Earth's atmosphere. For instance, high-powered microwaves or lasers could be employed to break down greenhouse gases like methane or carbon dioxide, reducing their concentration in the atmosphere. This approach would require immense technological advancements and careful calibration to avoid unintended consequences, but the potential benefits are undeniable. By targeting specific atmospheric layers, energy weapons could help restore balance to our climate system. Energy weapons could also play a role in protecting Earth from natural climate-altering events. For example, they might be used to intercept and vaporize incoming asteroids or comets that could trigger catastrophic climate shifts upon impact. While this application overlaps with planetary defense, it underscores the versatility of these technologies in safeguarding our environment. However, the use of energy weapons for climate intervention raises significant ethical and practical questions. Who would control these systems, and how would their deployment be regulated? The potential for misuse or unintended side effects is a major concern, especially given the delicate balance of Earth's ecosystems. International cooperation and transparent governance would be essential to ensure these technologies are used responsibly and equitably. Despite these challenges, the idea of harnessing space-based energy weapons to combat climate change is both innovative and inspiring. It represents a shift from viewing these technologies solely as tools of conflict to recognizing their potential as instruments of global good. As we continue to explore the possibilities, one thing is clear: the future of energy weapons may hold the key to not only defending our planet but also preserving it for generations to come. With this vision of energy weapons as climate solutions in mind, let's now consider how these technologies could enhance the safety and efficiency of interplanetary travel, opening new frontiers for exploration and discovery. As we venture further into the cosmos, the challenges of interplanetary travel become increasingly apparent. One of the most significant obstacles is the presence of space debris and potential threats that could jeopardize the safety of spacecraft. This is where space-based energy weapons could play a transformative role, not just as tools of defense but as enablers of exploration. Picture this: a spacecraft on its way to Mars encounters a field of debris left behind by decades of space missions. Without intervention, even a small piece of debris could cause catastrophic damage. Enter energy weapons. High-powered lasers or particle beams could be deployed to vaporize or deflect these hazardous fragments, clearing a safe path for the spacecraft. This capability would not only protect missions but also reduce the risk of collisions that could generate even more debris, creating a safer environment for future travelers. Beyond debris, energy weapons could also neutralize natural threats such as micrometeoroids or small asteroids that pose risks to interplanetary missions. By targeting and disintegrating these objects before they reach the spacecraft, energy weapons could ensure smoother and more secure journeys. This technology could be particularly valuable for long-duration missions, where the likelihood of encountering such hazards increases with distance and time. Moreover, energy weapons could serve as a proactive measure to safeguard critical infrastructure in space. For instance, they could protect space stations, lunar bases, or even future Martian colonies from potential threats. By establishing a network of energy-based defense systems, we could create a safer and more reliable framework for humanity's expansion into the solar system. However, the deployment of energy weapons for interplanetary travel is not without its challenges. Precision and reliability are paramount, as any miscalculation could have dire consequences. Additionally, the energy requirements for such systems would be immense, necessitating advancements in power generation and storage. International collaboration would also be essential to ensure these technologies are used responsibly and equitably, avoiding the militarization of space. Despite these hurdles, the potential benefits are immense. Energy weapons could revolutionize the way we approach space travel, turning what was once a perilous journey into a safer and more predictable endeavor. As we look to the stars, these technologies may well become the guardians of our cosmic ambitions, ensuring that humanity's reach extends safely and sustainably into the vast expanse of space. With the safety of interplanetary travel now in sharper focus, let's shift our gaze to another critical aspect of space-based energy weapons, their vulnerabilities to cyberattacks and the measures needed to protect them from sabotage. As we explore the potential of space-based energy weapons, it's crucial to address a challenge that often goes unseen but is no less dangerous: cybersecurity. In an era where digital threats are as real as physical ones, the vulnerabilities of these advanced systems to cyberattacks cannot be ignored. Imagine a scenario where a hacker gains control of a high-powered laser or particle beam weapon orbiting Earth. The consequences could range from disabling critical defense systems to causing intentional harm, turning a tool of protection into a weapon of chaos. The first major vulnerability lies in the communication systems that link these weapons to their operators. Whether on Earth or in space, these systems rely on networks that could be intercepted, jammed, or hacked. A single breach could allow an attacker to take control, manipulate targeting data, or even shut down the weapon entirely. To counter this, robust encryption and secure communication protocols must be developed, ensuring that only authorized personnel can access and operate these systems. Another concern is the software that powers these weapons. Like any advanced technology, they depend on complex algorithms and code which could contain exploitable weaknesses. Malicious actors could introduce malware or exploit existing bugs to disrupt operations. Regular software updates, rigorous testing, and the implementation of artificial intelligence for real-time threat detection are essential to mitigate these risks. Additionally, creating redundant systems that can take over in the event of a cyber attack would provide an extra layer of security. Physical security is equally important. Space-based energy weapons are often part of larger satellite networks, which could be targeted by cyber attacks aimed at disabling their power sources or propulsion systems. Protecting these components requires not only advanced cybersecurity measures but also physical safeguards, such as shielding against electromagnetic pulses that could fry sensitive electronics. International cooperation will play a pivotal role in addressing these challenges. Just as nations collaborate to combat cybercrime on Earth, they must work together to establish global standards and protocols for securing space-based energy weapons. This includes sharing intelligence on emerging threats, developing joint defense strategies, and creating frameworks to hold malicious actors accountable. While the risks are significant, the solutions are within reach. By prioritizing cybersecurity in the design and deployment of space-based energy weapons, we can ensure they remain tools of protection rather than instruments of destruction. As we continue to push the boundaries of space technology, safeguarding these systems from digital threats will be just as important as defending them from physical ones. With cybersecurity now in the spotlight, let's turn our attention to another fascinating application of space-based energy weapons: their role in securing and defending future space colonies, ensuring humanity's expansion into the cosmos is both safe and sustainable. As we venture further into the cosmos, the idea of space colonization becomes less of a science fiction dream and more of a tangible reality. But with this exciting frontier comes the need for robust security measures to protect these colonies from potential threats. This is where space-based energy weapons could play a pivotal role in ensuring the safety and sustainability of humanity's off-world settlements. Picture this: a thriving colony on Mars or the Moon, bustling with activity and innovation. While these colonies will be designed to withstand the harsh conditions of space, they will also need protection from external dangers such as rogue asteroids, hostile entities, or even rival factions. Energy weapons strategically placed in orbit or on the colony itself could serve as a first line of defense, neutralizing threats before they pose a risk to the inhabitants. One of the most immediate applications of energy weapons in space colonization is asteroid defense. As we've discussed earlier, these weapons could be used to deflect or destroy incoming asteroids, preventing catastrophic impact. But their utility doesn't stop there. In the context of a space colony, energy weapons could also be deployed to intercept smaller debris or micrometeoroids that could damage infrastructure or endanger lives. By maintaining a clear and safe environment, these weapons would ensure the long-term viability of the colony. Beyond natural threats, energy weapons could also safeguard colonies from human-made dangers. As humanity expands into space, the potential for conflict over resources or territory increases. Energy weapons could act as a deterrent, discouraging hostile actions by demonstrating the colony's ability to defend itself. For instance, a laser-based defense system could disable an approaching spacecraft or neutralize a ground-based threat without causing widespread destruction. This precision makes energy weapons an ideal tool for maintaining peace and stability in space. Moreover, energy weapons could be integrated into the colony's infrastructure, providing continuous protection without requiring constant human oversight. Artificial intelligence could manage these systems, monitoring for threats and responding in real time. This would not only enhance security, but also free up human resources for other critical tasks, such as research, construction, or exploration. However, the deployment of energy weapons in space colonies also raises important ethical and logistical questions. Who controls these weapons? How do we prevent their misuse? These challenges highlight the need for clear regulations and international cooperation, ensuring that energy weapons are used responsibly and for the collective good. As we look to the stars, the role of energy weapons in securing our future in space cannot be overstated. They offer a powerful means of protection, enabling humanity to explore and thrive in new worlds with confidence. But their success will depend on our ability to balance innovation with responsibility, ensuring that these tools of defense serve as a foundation for peace and progress. With the security of space colonies now in focus, let's shift our gaze to another intriguing aspect of space-based energy weapons: their potential to reshape international relations and diplomacy among spacefaring nations. As we consider the broader implications of space-based energy weapons, it's impossible to ignore their potential to transform the landscape of international relations. The development and deployment of these advanced technologies could redefine how nations interact in space, sparking both collaboration and competition on an unprecedented scale. Imagine a future where multiple nations have established a presence in space, each equipped with their own energy weapons. The mere existence of these tools could shift the balance of power, creating a new kind of arms race. Countries might form alliances to pool resources and share technology, aiming to create a unified defense system that benefits all parties. On the other hand, rivalries could emerge as nations vie for dominance over strategic locations, such as lunar bases or asteroid mining sites. Energy weapons in this context could become both a symbol of strength and a bargaining chip in diplomatic negotiations. One of the most intriguing possibilities is the creation of international treaties specifically addressing the use of space-based energy weapons. Just as nuclear weapons led to agreements like the Outer Space Treaty of 1967, energy weapons could prompt nations to establish new frameworks for responsible use. These treaties might include provisions for transparency, mutual inspections, and limits on weapon placement to prevent an escalation of tensions. However, enforcing such agreements in the vastness of space presents unique challenges, requiring innovative solutions and a high level of trust among participating nations. The role of energy weapons in space diplomacy could also extend to conflict prevention. By serving as a deterrent, these weapons might discourage hostile actions, encouraging nations to resolve disputes through dialogue rather than force. For example, a nation with advanced energy weapon capabilities could use its technological edge to mediate conflicts, offering protection to smaller or less equipped nations in exchange for cooperation or resources. This dynamic could foster a more collaborative approach to space exploration, where mutual benefit takes precedence over competition. At the same time, the potential for misuse cannot be overlooked. Energy weapons could be weaponized in ways that destabilize international relations, such as by targeting satellites or disrupting communication networks. Such actions could lead to a breakdown of trust, making it harder for nations to work together on shared goals like asteroid defense or planetary exploration. The challenge, then, is to ensure that energy weapons are developed and deployed in a way that promotes stability rather than conflict. As we look ahead, it's clear that space-based energy weapons will play a pivotal role in shaping the future of space diplomacy. Their impact will depend on how nations choose to wield this power, whether as a tool for cooperation or a catalyst for division. The choices we make today will determine whether these weapons become a force for unity or a source of tension in the final frontier. With the diplomatic implications of energy weapons now in focus, let's turn our attention to another fascinating application: their potential to aid in space exploration, clearing the way for safer and more efficient journeys beyond Earth's orbit. Now, let's shift our focus to how energy weapons could revolutionize the way we explore the cosmos. Beyond their role in defense and diplomacy, these advanced tools might also serve as invaluable assets for space exploration, opening up new possibilities for safer and more efficient journeys beyond Earth's orbit. One of the most immediate applications of energy weapons in space exploration could be clearing debris and obstacles from flight paths. Space is filled with countless pieces of defunct satellites, spent rocket stages, and other fragments that pose a significant risk to spacecraft. Energy weapons such as high-powered lasers could be used to vaporize or deflect this debris, ensuring safer passage for missions traveling to the Moon, Mars, or even deeper into the solar system. This capability would not only protect valuable equipment and human lives, but also reduce the need for costly and time-consuming maneuvers to avoid collisions. Another exciting possibility is the use of energy weapons for propulsion. Imagine a spacecraft equipped with a directed energy system that could propel it forward by firing beams of energy against a reflective surface or even into space itself. This concept, often referred to as laser propulsion, could drastically reduce the amount of fuel required for long-distance missions, making space travel more sustainable and cost-effective. By harnessing the power of energy weapons, we could potentially achieve faster speeds and reach distant destinations in a fraction of the time currently required. Energy weapons could also play a role in planetary exploration. For instance, they might be used to clear landing sites on asteroids or moons by removing surface obstacles or breaking down rocky terrain. This would make it easier for rovers or landers to touch down safely and begin their scientific missions. Additionally, energy weapons could be employed to extract resources from celestial bodies, such as by breaking apart asteroids to access valuable minerals or water ice, which could then be used to support future missions or even sustain human colonies. The potential for energy weapons to enhance space exploration doesn't stop there. They could also be used to protect spacecraft from natural hazards, such as micrometeoroids or radiation. By creating a defensive shield of energy, these weapons could neutralize incoming threats before they reach the spacecraft, ensuring the safety of both equipment and crew. This level of protection would be especially crucial for long-duration missions, where the risk of encountering dangerous space debris or solar flares increases over time. As we look to the future, it's clear that energy weapons could become indispensable tools for space exploration, addressing challenges that have long hindered our ability to venture deeper into the cosmos. By leveraging their capabilities, we can pave the way for more ambitious missions, from establishing permanent bases on the Moon to sending humans to Mars and beyond. The integration of energy weapons into our exploration efforts could mark a turning point in humanity's quest to unlock the mysteries of the universe. With this vision of energy weapons as enablers of exploration in mind, let's now turn our attention to the ethical considerations surrounding their use and how these powerful tools might shape the moral landscape of space technology. Now, as we venture into the realm of ethics, it's important to consider the moral implications of deploying energy weapons in space. While these technologies hold immense potential for exploration and defense, they also raise significant ethical questions that demand careful reflection. The very power that makes energy weapons so effective could also make them dangerous if misused or left unchecked. One of the most pressing concerns is the potential for weaponization. Space-based energy weapons, if developed without proper oversight, could escalate conflicts and create a new arms race among nations. The ability to disable satellites or target spacecraft from orbit could destabilize global security, leading to a scenario where space becomes a battleground rather than a shared frontier for exploration. This raises the question, who gets to control these weapons and how can we ensure they are used responsibly? Another ethical dilemma revolves around unintended consequences. Energy weapons, even when used for peaceful purposes, could have unforeseen effects on the space environment. For example, the use of high-powered lasers to clear space debris might inadvertently damage functioning satellites or disrupt communication systems. Similarly, the deployment of energy shields to protect spacecraft could interfere with scientific instruments or astronomical observations, potentially hindering our understanding of the universe. These risks highlight the need for thorough testing and regulation to minimize harm. The issue of accountability also comes into play. In the event of an accident or misuse, determining responsibility could be incredibly complex, especially in the vast and lawless expanse of space. Without clear international agreements and enforcement mechanisms, it would be difficult to hold nations or organizations accountable for their actions. This lack of oversight could lead to reckless behavior, further endangering both human and robotic missions. Moreover, the development of space-based energy weapons raises questions about equity and access. If only a handful of nations or corporations possess this technology, it could create a power imbalance, leaving others at a disadvantage. This could exacerbate existing inequalities and limit the ability of smaller nations or private entities to participate in space exploration. Ensuring fair and equitable access to these technologies will be crucial in maintaining a collaborative and inclusive approach to space development. Finally, there's the broader philosophical question of whether we should weaponize space at all. Space has long been viewed as a domain for peaceful exploration and scientific discovery, a place where humanity can come together to push the boundaries of knowledge. Introducing weapons into this environment risks undermining that vision, turning space into a contested and potentially hostile arena. As we continue to develop these technologies, we must ask ourselves, what kind of future do we want to create in space, and how can we ensure it aligns with our shared values? These ethical challenges remind us that technological progress must be guided by thoughtful consideration of its impact on humanity and the cosmos. As we move forward, it's essential to strike a balance between innovation and responsibility, ensuring that space-based energy weapons are used to benefit all of humanity, not just a select few. With these considerations in mind, let's now explore how these powerful tools might intersect with the growing space tourism industry and what that could mean for the future of civilian space travel. As we shift our focus to the intersection of space-based energy weapons and the burgeoning space tourism industry, it's fascinating to consider how these powerful technologies might shape the future of civilian space travel. Space tourism, once a distant dream, is rapidly becoming a reality, with companies already offering trips to the edge of space and beyond. But as this industry grows, so too does the need to address potential risks and ensure the safety of passengers. This is where energy weapons could play a pivotal role. One of the most immediate applications of energy weapons in space tourism could be in safeguarding spacecraft and their passengers. Imagine a scenario where a tourist vessel encounters space debris or an unexpected threat during its journey. Energy weapons such as high-powered lasers could be used to neutralize these dangers in real time, providing an added layer of protection. This capability could make space travel not only more appealing but also more secure, encouraging more people to take the leap into the cosmos. However, the integration of energy weapons into space tourism isn't without its challenges. For instance, the presence of such weapons on civilian spacecraft could raise concerns about their potential misuse. What happens if a tourist vessel is hijacked or its weapons systems are hacked? The consequences could be catastrophic, not only for the passengers but also for other spacecraft and satellites in orbit. This highlights the need for robust security measures and strict regulations to prevent unauthorized access to these systems. Another consideration is the psychological impact on tourists. While the idea of energy weapons might sound exciting to some, others could find it unsettling to travel on a spacecraft equipped with such powerful tools. Striking the right balance between safety and comfort will be crucial in ensuring that space tourism remains an enjoyable and stress-free experience for all passengers. On the flip side, energy weapons could also open up new possibilities for space tourism. For example, they could be used to create controlled displays of light or energy in space, offering tourists a unique and unforgettable experience. Imagine watching a laser light show against the backdrop of Earth or witnessing the precise targeting of an asteroid for scientific study. These kinds of experiences could elevate space tourism to new heights, blending adventure with education and entertainment. Yet, as with any powerful technology, there's always the risk of unintended consequences. The use of energy weapons in space tourism could inadvertently disrupt communication systems or interfere with scientific research. For instance, the deployment of energy shields to protect a tourist vessel might block signals from satellites or telescopes, hindering our ability to study the universe. This underscores the importance of careful planning and coordination to minimize any negative impacts. Ultimately, the relationship between energy weapons and space tourism is a complex one, filled with both opportunities and challenges. As this industry continues to evolve, it will be essential to navigate these issues thoughtfully, ensuring that the benefits of energy weapons are realized without compromising safety or ethical considerations. With that in mind, let's now turn our attention to how these technologies might intersect with space-based surveillance systems, and what that could mean for global security and intelligence gathering. Now, let's explore how energy weapons could intersect with space-based surveillance systems, a topic that holds significant implications for global security and intelligence gathering. Space-based surveillance has become a cornerstone of modern defense and intelligence operations, with satellites providing critical data on everything from military movements to environmental changes. But as energy weapons enter the picture, their potential to either enhance or disrupt these systems could reshape the landscape of global security. One of the most promising applications of energy weapons in this context is their ability to enhance surveillance capabilities. For instance, high-powered lasers could be used to illuminate targets from space, providing clearer imagery for reconnaissance satellites. This could allow for more precise monitoring of activities on Earth, from tracking troop movements to identifying potential threats in real time. Additionally, energy weapons could be deployed to disable or destroy hostile surveillance satellites, giving nations a strategic advantage in intelligence operations. However, the flip side of this technology is equally significant. energy weapons could also be used to disrupt or disable surveillance systems, creating vulnerabilities in global security networks. Imagine a scenario where an adversary uses energy weapons to blind or damage surveillance satellites, leaving entire regions without critical intelligence. This could lead to gaps in situational awareness, making it harder to respond to emerging threats or coordinate international efforts. The potential for such disruptions underscores the need for robust countermeasures and international cooperation to safeguard these vital systems. Another layer to consider is the dual-use nature of energy weapons in surveillance. While they can be tools for enhancing security, they can also be weapons of disruption. For example, a nation might deploy energy weapons under the guise of improving its own surveillance capabilities, only to use them to interfere with the satellites of other countries. This kind of covert action could escalate tensions and lead to a new kind of arms race in space, where the focus shifts from physical destruction to the manipulation of information and intelligence. The ethical and legal implications of using energy weapons in surveillance are also worth examining. While international treaties currently govern the use of space for peaceful purposes, the rapid advancement of energy weapon technology could outpace existing regulations. This raises questions about accountability and the potential for misuse. Who decides when and how these weapons are deployed? And how can the international community ensure that they are used responsibly without compromising global stability? Looking ahead, the integration of energy weapons into space-based surveillance systems could lead to a new era of intelligence and security. On one hand, these technologies offer the potential for unprecedented precision and effectiveness in monitoring global activities. On the other hand, they introduce new risks and challenges that must be carefully managed. As nations continue to develop and deploy these systems, striking the right balance between innovation and responsibility will be key to ensuring a secure and stable future. With this in mind, let's now turn to our final prediction, where we'll explore the long-term implications of space-based energy weapons for humanity, warfare, and space exploration. This will bring our journey full circle, tying together the many threads we've explored throughout this video. As we bring our exploration to a close, let's take a moment to reflect on the future of space-based energy weapons and their profound implications for humanity, warfare, and space exploration. Throughout this video, we've uncovered 25 detailed predictions that paint a vivid picture of how these advanced technologies could reshape our world. From directed energy weapons revolutionizing space warfare to the potential for energy shields and countermeasures, the possibilities are both thrilling and daunting. One of the most striking takeaways is the dual nature of these technologies. On one hand, space-based energy weapons hold immense promise for enhancing global security, protecting Earth from threats like asteroids and enabling safer space exploration. They could provide nations with unprecedented defensive and offensive capabilities, fundamentally altering the dynamics of warfare and diplomacy. On the other hand, their potential for misuse, whether through disrupting surveillance systems, escalating arms races, or creating new ethical dilemmas, cannot be ignored. The balance between innovation and responsibility will be critical as we move forward. Looking ahead, the integration of artificial intelligence into these systems could further amplify their capabilities, enabling faster decision-making and more precise targeting. At the same time, the vulnerabilities of these technologies to cyberattacks and the challenges of international regulation highlight the need for robust safeguards and global cooperation. The future of space-based energy weapons is not just about technological advancement, but also about navigating the complex interplay of power, ethics, and collaboration. For humanity, these developments could mark a turning point in our relationship with space. Energy weapons could play a pivotal role in securing future space colonies, enabling interplanetary travel, and even addressing global challenges like climate change. Yet, they also raise questions about the militarization of space and the potential for conflict beyond Earth's atmosphere. How we choose to develop and deploy these technologies will shape not only the future of warfare, but also the trajectory of human civilization. As we stand on the brink of this new era, one thing is clear. The future of space-based energy weapons is as much about the choices we make as it is about the technologies we create. Will we use these tools to protect and advance humanity, or will they become instruments of division and destruction? The answer lies in our ability to balance innovation with responsibility, ensuring that the benefits of these technologies are shared equitably and their risks are managed wisely. Thank you for joining us on this journey through the future of space-based energy weapons. If you found this video insightful, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest explorations into futuristic technologies and their impact on our world. Let us know in the comments, what do you think the future holds for space-based energy weapons? Your thoughts could spark the next big conversation. Until next time, keep exploring the possibilities. As we wrap up this deep dive into the future of space-based energy weapons, let's revisit the 25 predictions that have shaped our exploration. From the deployment of directed energy weapons in space to the potential for energy shields and countermeasures, each prediction offers a glimpse into a future where technology reshapes the very nature of warfare and exploration. These advancements could revolutionize how we defend our planet, secure space colonies, and even address global challenges like climate change. Yet, they also come with significant risks, from the militarization of space to the ethical dilemmas of autonomous weaponry. One of the most compelling aspects of these predictions is their interconnectedness. The development of laser-based defense systems, for instance, could pave the way for asteroid deflection technologies, while the integration of artificial intelligence into energy weapons might redefine the speed and precision of space combat. At the same time, the vulnerabilities of these systems to cyberattacks and the challenges of international regulation remind us that innovation must be paired with responsibility. The future of space-based energy weapons is not just about what we can build, but also about how we choose to govern and protect these technologies. As we look to the horizon, it's clear that these advancements will have far-reaching implications for humanity. Will they become tools for peace and progress, or will they escalate conflicts beyond Earth's atmosphere? The answer lies in our collective decisions, how we balance ambition with ethics and competition with collaboration. The potential for these technologies to transform space warfare and exploration is immense, but so is the need for thoughtful stewardship. Now, we turn the conversation over to you. What do you think the future holds for space-based energy weapons? Do you see them as a force for good, or do the risks outweigh the benefits? Share your thoughts in the comments below. Your perspective could spark the next big discussion. And if you enjoyed this journey into the future of technology, don't forget to like, subscribe, and hit the notification bell to stay updated on our latest explorations. Until next time, keep imagining the possibilities and shaping the future.